Hey guys, so let's go into how to transform that mess, which is the current state of the value stream map. A lot of push system going on, a lot of inventory between steps, with little amounts of add value time. How to interpret that, how we look at that and make it more lean, right? Before that, I'm going to show you the t-shirt of today. So it's a Star Wars t-shirt with find out if you guys know what is the name of this ship here. I don't think I used this one before, but it's getting pretty tight. It's good that the semester is ending because I don't have many shirts to show you. Maybe I have to start buying new ones. This is actually a new one. I found out when I was buying lightsabers for my two girls. Anyway, let's go to lean value stream. So we know that we have this 4 steps to the value stream map. You always need a future state, right? That's the goal of the map, of a value stream map. Have a current state just to find out where you are. It's a picture of a day. And then, okay, how can I make it, more lean? How can I reduce the waste and improve the efficiency, improve the quality, improve the throughput, whatever metric you wanna get better on. So usually you draw in pencil paper, and it's something that you make mistakes, and when I do this in companies, I put like a butcher paper or a flip chart, big paper, post-it notes, and it's a process of getting everything done. It's a collaborative thing that you have to do with the team of people from the company that know different aspects of what's going on. The current is the starting point, right? And then you create the future state, thinking about use whatever you have available, right? So uh, you can remove, reduce batches if it's possible, combine things, change the layout, change the information flow. That's things that we usually do, but don't think about, okay, let's take everything and put a totally new production line that will take 10 years or 2 years to be done. And that's our value stream mapping project. No, lean is about, simple, direct improvements that will have a big impact, and not thinking about kind of a big project, right? More like a small and constant improvement. So we're going to look at some concepts here: continuous flow, very important, system efficiency, takt time, and some other ones. First is continuous flow. So imagine that you have 3 production process. Each process has a cycle time of 1 minute. Okay, so we have this saw here, this drilling, and this welding process here. Each one take 1 minute. Let's say that our batch is 60 parts, which means that you're only going to transport this when I have all the 60 done, right? So how long it will take to go through the all the 3 process? Think about that. Write it down. See if we got it right. So first one, it will take, so I have 1 part here, takes 1 minute, I have 1 part there, 59 parts here. And then every minute, I'm gonna process a part. So after 60 minutes, I'm gonna have an inventory of 60 parts here between the first and the second process, right? Then I'm gonna transport, and then I'm gonna start doing the second one, and then I'm gonna do it. So it's 60 more minutes, and then I'm gonna do it again, 60 more minutes, right? So at least 180 minutes if my transportation batch is 60 minutes, and if those steps are far away from each other. So that is a big a number in terms of lead time, because what is the value at a time on those 180 minutes? So if you take a part in the beginning and it will take 180 minutes to go to the end, how much of that time that part was being added value on? 3 minutes, because it's only the 3 processes. All the rest of the time, the part was waiting, right? And I say at least 180 because the equipment can break, the operator can lose some time trying to find the part, or whatever it is, don't have the tool, the correct tool, whatever it is, it can make a lot more than 180. So what is the lean thinking mindset I wanted to look at? How do I take this process? We have a lot of inventory, a lot of waste, a lot of lead time, and make it as as smooth and quick as possible without changing the process itself. So I'm going to take these 3 steps and I'm going to rearrange the layout and put one after the other. So I'm going to take apart, still a batch of 60. We're going to take one, and we're going to go to process 1, process 2, process 3, and then it's done, right? How long it will take, I still have the 60 in the beginning, and I'm going to wait until I build the 60 at the end. How long will that take? Again, I don't change the process, I just reorganize it. So the first part takes 1, 2, 3 minutes to get out, right? So 3 minutes, I have one part ready, already available. And then I have 59 that are coming, and each one will come out one every minute. So it'll take 62, 3 plus 59 minutes to get my batch of 60 parts done, right? And that's the power of the one-piece flow, okay, or continuous flow, is that you can drastically reduce your lead time without changing the equipment or changing very little of the equipment if you think in creating this flow of products, get in and get out, get in and get out. And I implemented several of those continuous flow in manufacturing process, and people were really amazed and said, wow, I already have a part ready. Usually take days to have something ready. When we implement this, it's also called manufacturing cell, when you have the continuous flow, and we're going to see an example of that, I get the part ready in questions of minutes, right? So this is the power. You can respond quickly, you have the part quickly, you can drastically reduce your inventory and your waste because someone was moving and carrying things around. How do I organize that continuous flow, right? So we have this layout, which is called divided by processes, which is very typical in companies. The companies, let's say I'm taking this case, all my lathe equipment put in one side, all my milling department put another side, all drilling in another part, all grinding in another part, or all final inspection in another part, divided into these 1, 2, 3, 4, 5 areas of my plant, and I dedicate it to processes. Well, it seems like a good idea, but then the product have to go to all the steps, right? So getting out of here in the shipping, the product have to find a late machine to do this process here. Then you have to go to the other one, have to go to the other one, have to go to the other one. And guess what? Between all those steps, we have space and we have transportation batches because you're not going to take one and go to the next step. You're going to do a whole pallet. And at the end of the day, the lead time, the inventory, the waste get huge amounts, right? The totally other opposite of that will be a continuous flow with an assembly line. Assembly line is saying, okay, instead of organizing by processes, I'm organizing by product. So I have one product that goes into all those steps, right? And the steps are going to be aligned here, okay? So in this case, I don't have a lot of flexibility. So the organized by process has a lot more flexibility. You can go different ways. If I organize by line, I don't have any flexibility, have to go through those steps. So all the products that have to go there have to be the same process steps. So this is reduce enormously the lead time, and that's kind of the assembly line concept, right? Developed by Ford and others, but it is still not implemented in a lot of companies. The manufacturing cell is one that takes a little bit of the benefits of both of them. So the process layout has a lot of flexibility. The line flow has no flexibility, but a lot of productivity, right? So take both of them together and created this cell, which is not a new concept, but Toyota and the lean companies implement that a lot more than any other company. So this is the best type of layout because it has some flexibility because you can jump sometimes from one side to the other. It gives a lot of flexibility in terms of rearranging the number of operators. So if you have a line, there's no flexibility of changing the volume too much because you don't want your operator to go 1, 2, 3, 4, 5 seats and then go back to the beginning of the line, right? So like this. If I design a line with 100 people, you know, it will not work well with 50 or 25 or 110 people, right? In this case, I can rearrange the tasks very easy because I have the two sides of the line, right? So this operator is doing step here, here, and here, right? And this one is doing this one is doing this. You have the curve, so you reduce a lot the space that you use. You use less space, you increase productivity, and you gain flexibility at the same time. So that's why the what you call the U-shaped line, and you can see why it's a U shape, right? You guys are smart. That's a U-shaped line.